we're going to do another example to find the greatest common factor. Just a reminder, factors are the numbers you multiply together to get another number, and the greatest common factor, the GCF, is the largest number that divides evenly into two or more numbers. We're again going to solve this using factor trees. We're going to find the GCF of 9 and 15 because a lot of times when students see odd numbers, they think that they're prime automatically and they don't have any factors, and that is not always the case. So I'm going to set up my tree for 9 and my tree for 15. Looking at 9, well, I know 1 is a factor of 9. I know 2 is not because 9 is an odd number. Then I get to 3. 3 times 3 equals 9. Now, since 3 is a prime number, its only factors are 1 and 3, I circle it. And then I can circle this one as well. So only factors are 1 and 3, so I'm done and I can circle it. So now I come down and set up my list for 9. 9 equals 1, because it's a factor of every number, times 3 times 3. Do a quick check. 1 times 3 is 3. 3 times 3 equals 9, so that list is correct. Your next one is 15. Well, I noticed there's a 5 in the ones place. Anytime there's a 5 in the ones place, that number is divisible by 5, so 5 will be a factor. If there's a 0 or a 5 in the ones place, 5 times something will give you that number. In this case, 5 times 3 equals 15. Now stop and think, what are the factors that when multiplied together equal 5? Well, the only factors of 5 are 1 times 5, so I'm going to circle that. And then same thing with my 3. The only factors of 3 are 1 times 3, so I'm going to circle my 3. Now come down here and set up your list. 15 equals 1 times 3, because I'm going in order from least to greatest, times 5. Now I'm going to circle the numbers they have in common. So I'm looking for a pair of numbers. So I have a pair of 1s. I have a 1 in both lists. Then I have a pair of 3s. I have 3s in both lists. But then I have another 3 and I have a 5. Those do not have a pair. They don't have a matching number in the other list, so I can cross those off. Now remember, you just pull out one number from each of the pairs you circled to find the GCF. So GCF equals 1 times, because we're multiplying, we're looking at factors, times 3. So GCF of 9 and 15 equals 3. 3 is the largest factor that goes into 9 and 15 evenly. Let's look at one more really quick, because this is another one that tends to trip students up. If I want to find the GCF of 11 and 20. Using the trees, I set them up just like we've been doing. So my tree for 11, my tree for 20. Now for 11, you have to think about what factors of 11, what factors you can think of. So what you can think of that multiplied together equals 11. Well, I know 1 times 11 is 11. Nothing times 2 is 11. 2 does not go into 11 evenly. I know that because 11 is an odd number. If I think about my 3s, if I count by multiples of 3, 3, 6, 9, 12, I skip right over 11, so 3 does not go into 11 evenly. 4 does not go into 11 evenly. 4, 8, 12. Again, I skip it. 5 does not go into 11 evenly because it ends with a 1 and not a 0 or a 5 in the ones place. 6 does not go into 11 evenly. 7, 8, 9, and 10 do not go into 11 evenly. So 11 is a prime number. So the only factors of 11 are 1 times 11. So since it's prime, you can either circle it up here or circle these factors right here. Now I'm going to make my list. 11 equals 1 times 11. Now look at your 20. It ends in a 0, so I know it's divisible by 10 and by 5, definitely. It's also divisible by 2 because it's an even number. So I'm going to do 4 times 5. Now I need to break down my 4. 2 times 2 equals 4. I'm going to circle both of my 2's because the only factor of 2 is 1 and 2. Now I'm going to circle my 5 because the only factors of 5 are 1 times 5. And now I can make my list for 20. Remember, 1 is a factor of every number, so that's first on your list. 1 times, I'm going to go from least to greatest, 2 times 2 times 5. Now, just like usual, you circle the numbers that match. So you're looking for a pair. So I have a pair of 1s. I don't have an 11 in my list for 20, so I can cross that off. I also do not have a 2 in my list for 11, so I can cross off those 2's. And I do not have a 5 in my list for 11, so I can cross off that 5. That means the only number that I have a pair of is 1. So GCF equals, you pull out one number, remember, one number from your pair. In this case, my GCF just equals 1. 1 is the greatest factor both of those numbers have in common.